Welcome to this sessions on Introduction to Neural Network. In these presentations, we will explore how neurons layers and activation functions work, the essential components that make neural networks so powerful. So, what is a neural network? Neural networks are inspired by the human brain. They consist of artificial neurons or nodes that process information. These neurons are connected to each other and each connection has a weight, a number that determines how strongly one neuron influences another. Here you see a simple network diagram where inputs flow through neurons and connections, weights to generate an output. This mimics how our brain processes signals. Anatomy of neuron. So now let's look inside a single artificial neuron. The inputs are features or data points shown here as x1, x2, x3. Each input has a weight attached to it, which represents its importance. The neuron takes all the inputs, multiplies them by weight, and computes a simulation that the combined singular. Finally, the activation functions decides whether the neuron fires or not and what output it should produce. On this diagram, notice how the arrows represent inputs, the weights are attached to them, and the activation function sits at the end to decide the outputs. Layer in neural network. A neural network is not just one neuron, it's many neurons stacked into layers. The input layer receives raw data like features from a dataset. The hidden layer sits in the middle. They transforms input into more abstract patterns. The output layer produces the final predictions or decisions such as a classifications label or numerical value. This illusion shows three layers, inputs on the left, hidden layer in the middle, and output on the right. The arrow represents connections between neurons. Forward propagations, the journey of data. When we pass data into a network, it travels forward through the layers. This is called forward propagation. At each layer, the data is transferred into more abstract features. In image recognition, the input pixels are first processed into simple edges, then combined into shapes, and finally recognized as objects. Notice here how the arrows show data flowing from the input layer, hidden layer, output layer, symbolizing this forward journey. Activations functions, why they matter. So activation functions are critical because they add non-linearity. Without them, the network would behave like a simple linear module and fail to capture complex relationships. With activation functions, network can recognize interact patterns like shapes in image or meaning in speech. Common activations and functions. Here are some popular activation functions each shown with its curves. Sigmoids, compress value between 0 and 1, useful for probabilities. Tanh, output values between -1 and 1 centered at 0. ReLU, rectified linear unit, output the maximum of 0 and x simple and very fast, the most widely used today. Neural network in actions, handwriting disease recognitions. Let's see an example. Suppose we want to recognize handwriting disease. The inputs layer receives a 28 into 28 pixel image of the digit. The hidden layer extracts features starting with strokes and lines, then shapes. The output layer finally predicts the digit between 0 and 9. Key takeaways. To recap, Neurons are the building blocks combining inputs, weights, and activation functions layer. From the architectures, stacking neurons into input, hidden, and output stages. Activation functions provide the sparks of non-linearity, making it network capable of solving complex problems. Next step. Next step, we will dive deeper into how neural networks actually learn during training. That means exploring back propagations, the algorithm that adjusts weight and gradient descent, the optimization method that minimizes errors. So that's all. Thank you.